Hello, so we have to solve cosine 2x equals root 3 over 2, where x is more than or equal to minus 2 pi and less than or equal to 2 pi. So first, we have a double angle here, so let's just say 2x equals theta. So cosine theta equals root 3 over 2. Okay, so now since we know the unit circle, we know that theta equals arc cos root 3 over 2, and we know that looks like this, or like this, where this is root 3 over 2 and minus a half, and this is root 3 over 2 and positive a half. So these are the quadrants where cosine is positive. So this angle is pi over 6, this angle is negative pi over 6. Okay, so we know that theta equals, we'll donate it as plus or minus pi over 6, and then we can plug in 2x for theta. So x equals plus or minus pi over 12. So those are the solutions we have so far. But we know this cosine function, it does repeat. So let's erase all of this. I'll remember those numbers. Okay. So we had x equals pi over 12, and x equals minus pi over 12. Now we know this cosine function repeats, and the period is the 2 pi over the coefficient of x, which is 2, which is equal to pi. So this whole cycle of the cosine function repeats every pi. So we can apply that here. So the general formula would be x equals, with no domain restrictions, pi over 12 plus n pi, and x equals pi over minus pi over 12 plus n pi, where n is part of the integers. So these two solutions here, this is when n equals 0. Okay, and for n equals 1, let's take a look. I just dropped my pen. Okay, so x will equal, well, that would be 13 pi over 12. We're just adding 12 pi over 12. Then over here, if we add 1 pi, that would be, I believe, 11 pi over 12. So these are within the domain, so these also work as solutions. How about, let's try n equals minus 1. So first we'll have to, we'll find minus 11 pi over 12, and x equals, I believe that would be minus 13 pi over 12, and these are also within the domain, so these do count. Okay, let's try n equals 2, and it's not working. N equals 2. Okay, so we just have to add 2 pi, so 1 pi plus additional 24 pi, that's 25 pi over 12. Now this is actually more than 2 pi, so this cannot count as a solution. It's outside of our domain. Let's try it with this one here. I believe that would equal, I think that would equal 23 pi over 12, and that is within our domain. So we have another solution, and since the cosine graph here is symmetrical, we'll try n equals negative 2. So I believe that the x here would equal minus 23 pi over 12, which is within the domain, and this one would equal minus 25 pi over 12, which is not within our domain. So in total we get 1, 2, 3, 4, 5, 6, 7, 8 solutions, and our solutions are right here. So what's really important is you have to keep in mind that this the cosine function does repeat, and you have to solve for the period, and then you can find the general formula and then apply the domain. Thank you.